Imagine for a moment that you are running small company. You are running the ice cream stands, set of the ice cream stands on the beach, and it's April time frame. It's still cold outside, but you already sun and already see some green, which means that the winter is over and the summer is coming. You have probably 3 months if you want to do anything with your business, because then July it's starting. One of the things you want to do is to improve your forecasting, because you want to have every time enough ice cream on the stand and not get that wasted, because sometimes electricity going out, or even worse, if you don't have enough ice cream, people will be pretty angry. So you are looking for the forecasting problem. Basically, forecasting. You have data from last few years, and you are looking for the person who can help you with. You have two options. You have Tanya. She's doing PhD in computer science in AI. And when you were talking with her, she was talking about state-of-the-art deep learning, a lot of the acronyms. Then you have John. And you know John because he was actually working with you during his high school. He was working in one of your stands, and he's still in the undergrad. He's finishing, but he was more talking about data, how much ice cream he understands. Who do you think is better suited for his job? Who do you think is going to be better to help you with this? I'm going to surprise you, but John is going to be much, much better because he understands the business. He has a domain knowledge. He will understand one thing, that even if you do have the data of your sales, one thing you don't have in your data is very important, because weather is quite an important indicator how many people are going to be on the beach. Of course, that means how many people are going to be on the buying ice cream. So getting the data, getting everything together from the data, from machine learning perspective, from the data to the end is one of the things which we see more and more, getting more and more important. So that domain knowledge is starting to be more important than actual deep learning understanding of the algorithms. And that's where the idea of the data cloud, and the importance of the looking from the beginning, where you get your data, where you get the different data, where you enhance your data, and then use them in your prediction is coming. And that's where it is important. It's not starting to be not just about the pure in the production, in the enterprise world, not just about let's train the biggest algorithm, let's do the biggest thing. It's about all the integration from your little data, getting from the additional data, in this case, getting the data into it. And then we have a lot of tools which are helping you to actually utilize that data. And it's something which is already understand in the industry. If you're looking at what is the most important thing for the next few years, as a research from Boston Consulting Group, is getting data and using the data with machine learning. Because having the data just on your disk, it's just your cost. If you don't use the data, it's not useful. You can use that in analytics, in the showing up to the analysts, to the people, or you can use them automatically in machine learning models in the machine learning automation. So basically, more than a third of the companies are recognized, but that's usually not easy, because we see 68% of the companies are not able to realize the value of the data. Because, I don't know how many of you have been in a company where you had a sales forecast or any discussion, see the data on the paper and say, no, maybe this is not wrong, we need to adjust it. If you don't use data directly as going out of the system, those data are not very usable. So the multiple data copies, quality of the data, disconnected data is not just having them in a database, it's about governance, usability, seeing the data. And again, those are tools, abilities which are able to help you. We are looking on the data as the journey from the data to the value. Not just having them on the disk, not just getting them in, but the value is the most important thing. We need to get from that the data, from the data points which are coming in. Yesterday, sales of the ice cream. what we are going to do with that, how we are going to make it actionable, how we're going to use that that data in our business and in our business enterprise, government institution, any other institution. We are building set of the tools. Most of them are ready. You will see more and more. You'll see some significant amount of them last week in the Google Next, which are helping you from the beginning, from collection of the data through the data engineering. Here are data flow, which are managed services to process Google scale of the data. We are internally using them to do we're using the same technologies to create our own management. Do the data analytics, store the data, structured data, unstructured data in BigQuery, and then use them through the Vertex AI, through the Looker, through the tools to run the machine learning and run the analytics from the beginning to the end. And of course, there are much more tools within this environment. Don't think that those tools are as a kind of use it all of them or none. Think as a Lego box. Each of them works very well together. So you can build your house from those blocks. Or if you decided to do it slightly differently, you can have your Lego rocket and the stabilizers will be from a piece of wood, something else. Basically, it will fit. How do I know? But the rocket is still in my room back in my parents' house. So those are integrated tools which you can use one by one. Those are tools for different personas, different type of the people inside of the organization, not just for the software engineers in your company. Working for the developers, which are just accessing intelligent applications, which are just accessing models, for example, for making predictions, which are accessing APIs. If you want to know what is on this image, you don't need to train the model. You just send the image to the API, get the call, get the information out of that image. It's already pre-trained. If you need to do that slightly differently, of course, for the data scientist and for machine learning engineer, there are different tools which help you to build that your customer or that your specific thing. Then there are for business user data analyst. Whether we are talking about the visualization from basically getting the data into spreadsheet and building your own, or visualization on the Looker, which is a visualization platform of the data, or using natural language to ask the data. We have the BigQuery has the capability to ask a natural question in your language that will be translated into SQL and will be run on your data warehouse, and you will get the answers. So there are different tools, different things which are for the different personas in the company. What we are looking for is democratizing the data and AI inside of the organization, where you don't need PhD to run machine learning, but you don't need PhD to run 15 terabytes of the data processing of your data. You can do it simply by writing simple code and let the serverless platform, the platform which can scale up to the larger workloads to do it for you. Whether we are talking about the ingesting the data, you're getting streams of the data from your, for example, from IoT devices. You get messages from the mobile phones. You get large amount of data ingested into the platform, into different services, and then utilize them with the different services which are inside of the Google Cloud platform. And Google is pretty much undisputed leader in the AI and data. If you look on the number of papers for the conferences, we are probably still producing like double than the second company or institution. We are competing in this case, even with academic institutions, than anybody else. So whether we are talking about deep learning, whether we are talking about large data processing, whether we are talking about even system architectures, we are undisputed leader in this area. You see that in the lots and lots of the consumer products, maps, photos, Gmail, search. All of these are things which are quite widely used. There are a few things which are very popular but not very widely used. AlphaGo, for example, the set of the machine learning algorithms, deep learning algorithms, which were first to beat Go. AlphaFold is another one, which was the first one which are able to predict proteins. And now drug companies are using these algorithms to test their invention, their environments. What does it mean but how that's important for the enterprise and for the governmental institutions? One of the things which we are trying to do as fast as possible is move everything what is coming from our research into the two streams, open source and the products on the GCP platform. And you can see here even we are kind of significantly speeding it up. One of the oldest things which significantly everybody using is Hadoop. That took quite a while moving out from the Google paper into the real world user. We do have the Dataproc, which is Hadoop Spark cluster as a managed service. There is more coming. Dremel was first SQL warehouse, which was disconnected between the data storage and compute. Basically, first warehouse which were fully scalable. It doesn't really matter how much data do you have. If you need more processing power, just more processing power. If you need more compute, you add more compute. It used to be that you need to add both every time you increase the data or the processing power. That takes some time. We have it in BigQuery and in Apache Drill as an open source. Today, the last one, which kind of happened in less than a year from the research paper, was something which is called approximately nearest search. If you want to know two images, how different they are, how close they are, or you have a million images, and you would like, okay, what is the most similar image to the image I have? Then you are using algorithms called approximately nearest search, nearest neighbor, which is basically giving you what is the closest image there. So the algorithm and the paper will scan. It is open source already. Less than a year, we have a VertexAI matching engine, which is managed service doing that for quite a large number of the clients already. So a lot of the image search, text search on the internet is based on this algorithm. So we are speeding up, moving from the research to the production, to the availability of the service. Basically, you need to have a credit card, and you can use those year and even sometimes in less than year old product research results in the services. So let's go back to my example at the beginning. I was talking about the forecasting, and that basically with structured data problem, there are three types. We see forecast, classification, and regression. All of them we can do support pretty automatically. I will be talking about forecasting, and we'll show you how AutoML is actually running. How you can run the machine learning without a PhD, without that. So what we are doing is basically getting the data in our products, getting the data, set the training budget, because you can train and spend years trying to find smaller, slightly better algorithm, but you say, okay, I'm going to spend only 6 hours of the training, then magic happen, and then profit. So then AutoML is train the model, and you have the model which you can use in the online prediction, put it as a REST API, prediction inside of the BigQuery, inside of your SQL. So you have the SQL, ML predict as one of the field, and then your business analyst in his dashboard will see the machine learning results. Of course, that's for some significant amount of the use cases, not all the time. So sometimes we need to get it slightly deeper, but for the 80% of the use cases, that's not what you need. That's basically all this is hidden from you by just let's run the AutoML model. What's happening behind is data pre-processing. We'll need to check whether the values are correct, whether all the numbers are numbers, and there is no text, for example, data augmentation, if we do some automatic augmentation, then finding the right model, and then run it in the what we are replacing is pretty much this level of the deep learning. If you want to do it on your own, you can. There's a tools for that for your running. If you want to do, and you have, for example, instead of the set of the ice cream shops, you are running large national retailer with millions and millions of the items in your database, probably AutoML is not for you. So there is a way, there are tools which can help you to build your own tools. And this is just for example what's actually happening inside of the AutoML. The model selection, the full architecture tuning, tagging ensemble. That's basically set of the research which happened inside of the Google and now in the product. If you want to know what is happening behind, there's a paper behind it. It's not black box. It's not something you don't see inside of what is in there. You can go and you can read the paper how it's done, just implemented inside of that. What is the benefit of just using the open source version of that on your own infrastructure? It's fully managed. It's when we're getting the newer version, when we're getting the newer research, you will see that your model is automatically better. You get better model. You don't need to implement it. So most of the things, if I'm looking on the AutoML, it's getting improved. If you run the same process with the same data 2 years ago, when, for example, AutoML for images went out, and today you will get better results today. Because we are moving improvement from the research into the production pretty fast. So let's get just this is theoretical. So I will give you just a few slides how in reality it works. What does it mean? And this is just the console. Of course, everything what you see inside of the Google Cloud Console, you can do through REST API, you can through the command line. If your engineer want to do it in Python, Go, Curl, directly from the command line, everything is possible. Everything what is inside of the console with just the user interface to the API. Okay, I create the data set. This is set of the steps what I need to do to get forecasting model into the production. I create a data set. Where's my data? Link it to the BigQuery or to the CSV file on my disk. Getting that into the platform to know where it is. I can use as much of the domain knowledge as I want to. Of course, if I'm doing forecasting, well, I'm forecasting which field of that is forecast. Actually, I'm trying to get. So what is the target column? Because forecasting is time series, I need, okay, where is the time? Where is the date time, or something similar in that? The platform will recognize if you have table with only one data type in the table, okay, it will get that. That's probably it. You can change it. And then there are a few little more things which can be done to improve the results. So it's not like I just put the data and that's it. You can, there are some reasonable defaults, but you do have few options to improve it. Forecast is usually about the future. So how much data during the moment forecast I do have, how much past data do I have? In this case, I have 7 days of the data, and I want to forecast for the next 7 days. I can have a 1 year of data and forecast for the next few days. I can have a month of the worth of data and forecast for the next month. Depends how much stability in my forecast I do want to have. Of course, longer forecast, as we all know, longer forecast you get, the less reliable it is getting. And this is where the domain knowledge I was talking about is starting to be. Not all of the data in your table are relevant. Some of the data are more important, something else. You can go just with the defaults, and that's usually what I recommend to my clients. Just start with the default and then improve it step by step. But you do have a lot of possibilities to improve the data by adding the information. Okay, is it time-specific information in this case? Because we are doing forecast. I can just delete this irrelevant information, or is the information which is correlated. If I do have in my sales data the number of units I'm selling and the cost what it was, those are correlated information. That's not additional information. Just I will delete one of those one of those items from the data, not just overburden the model, because more data I send, bigger budget I should set to train it. More data means more training. So I want to send only the most relevant data to have my budget, almost have my budget mode use. Last thing I need to do is how many hours, how much I'm willing to spend on this training, because it's as I said, it's very easy, especially on a large data set. If you set up, I think 9,999 is the maximum you can. It will be running for that hour, for the amount of the hours. That's not from the budget perspective, and from your time perspective, you don't want to weigh that. So set up your training budget, how much I want to have. Usually you're getting something small at the beginning, get a feeling, and then if I need more better model, I just get more bigger budget for the training. And then start the training, that's it. And then you have your forecasting model, which can be used easily in production. I have the evaluation, and I can just create a prediction. Here's the data which I have inside in the moment of the prediction. Not all the data which I have in my table in the past, I have during the prediction. This is the prediction data, this is the input, and this is the output. And I have the outputs ready. So my message here is it's important to start using the data in the reality. We are having the tools for able to use the data without getting through the building the model, 6 month, 9 month building the model. You can have value of the data pretty fast from the data to the model prediction. Important thing, all of these are integrated from the beginning. So we can have a flow of the data from that ice cream stand on a daily basis. Somebody will from the register send the message, either IoT or some different message to the bus stop. That will get to the BigQuery, that will get to the data warehouse. That data warehouse will run the prediction model, forecasting for what's going to happen in the next few days, and then means you know how much you need to order ice cream for the next few days. Thank you. Any questions?
So let me just probably use this opportunity to ask this question. I know that sometimes the data set that you have might also be influenced by the quality of the data that you do have. So I was wondering, though, yes, you have all this nice stuff coming from Google. So how do we ensure that side of it, the data collection side of it, is this something that the system is built to take that into consideration or not?
So, do we have automated quality control of the data? No, I wish we have. I wish somebody has. Unfortunately, life is not that easy. So there is no automation, but there's tools which guide you to that. First, the most important thing is data lineage. So you need to know when we are having prediction on the forecast, how I get to that data. So that's basically some kind of auditing. Data catalog and data governance. We do have the tools which are able to give you the information. Okay, I have the model here. That model was trained on this data set. That data set was created by this batch, Spark job, for example, from this source table. That source table arrived from this point. So you do have that. Second, we do have anomaly detection inside of the tool. So if you have something completely out of ordinary, let's take one-year stand on the beach will sell $2 billion of ice cream one day. Yeah, something has happened. There is a dot missing in that count. That's something which can be recognized. If it's just slightly different, just instead of $1,000, it's 1,005. There need to be some other way to check it. We do have the tools which help you to check it, but not the automation tools. Unfortunately, nobody yet invented. I'm looking forward to that. That will ease my life significantly.
Thanks.
Because if you look on the, and that's here, 68% of the companies are able to analyze the value of the data. The quality of the data is probably 50% of that.
Okay. I was wondering why 68.
That's the Accenture 2019 study. But yeah, I haven't read detail, but if I look on my experience, yeah, 50% of half of the failed projects are the quality of data. And that's why it's important to integrate tools. That's why it's important to have a dashboard, not just sending the data to the machine learning. Because if you are not using the data in a daily basis, just throw it into the model, the chance that the data are not correct is very, very high. If you're using the data, somebody is using the daily basis in operational level, that means somebody is relying on the data. That means we have much better chance that data are correct and quality.
So the machine learning itself, right, that's proprietary to Google. And with the user providing data set, who then becomes the owner of that data set?
So on the GCP, everything is yours. Okay. On the GCP, we don't see your data, we don't look on data. There's a very significant difference, I mean, to be very clear, about the consumer side and the enterprise side of the Google. Okay. Just for the consumer side, if you go and click somewhere on our ads, yes, we do have the data and that information on the improving the models. If on the enterprise side, no. And there's a very, very big wall between those sides. Just for the my personal experience, I was doing research before I joined Google. I needed some data from the Google, which are pretty much public, but all I needed to do is submit one form, and I got the data. It's basically the image data set. I asked the same inside of the Google. I had to go through the committee why I didn't need the data. Yeah, so the measurement and the tools to make sure that your data are, Google has, even if you don't trust me, and you shouldn't, by the way, there is a confidential computing. There is a area of the Google Cloud which is saying everything is encrypted by your keys, not just data which are in the storage, data which are between the computers, but even the data on your running on the computers. So the level of protection is significant, and we do have in this area a few customers which do require that. So those I/O data. If there are some moments when we use it, you know that. So, and I was mentioning the API for the image recognition. If I think for image recognition as well, there is a possibility to say, okay, you can use our data for uptraining your model, which means your price is going to be probably 10% or significantly lower than the regular price, but you need actively to say, okay, you can do that. If you don't say anything, you don't use that. Even to improve the models which we are running for those APIs.
Okay. Those image analysis models, you've mentioned previously KNN for search and image recognition. Do you use those also, or a different set of models for feature extraction from images like satellite or EO images?
Yes, those are always slightly different. Yeah. So there are two things: model architectures. No, we have some kind of zoo of the model architecture that we are using. The model weights and the training models, yes, those are usually for different use cases, different because they are trained on different data. But model architectures we are reusing very significantly. When you, for example, 2 years ago, we moved from we basically by our AutoML different level, which is called neural architecture search. We found a new architecture for the image recognition, efficient net. Basically, that architecture is now used everywhere, but trained on different data. Because satellite images, medical images are much, much bigger than, for example, images which are on the web. So there are different sizes and different reprocessing. Very good. Thank you.